Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at functions. So the idea of a function is very important in mathematics. We can see a function as a map from one set to another. So that map is a function if for each input there is one and only one output. Now that probably sounds a bit weird, but the point is in maths we want to have a case where we put like one number into a formula and we get one answer. It's very important in things like computer science. So that's the idea here of a function. So a map is just a way to get from one set to another. It like pairs up elements from the first set to the second set. For our purposes, we call the first set the domain and the second set the range. So the domain is the set of inputs, the range is the set of outputs. So this here, this map as indicated by the arrows, is not a function. A function requires that you never have an element in the domain, you never have an input value that's mapped to more than one output value. So here A, an input value, is mapped to both D and F. So just having one input that maps to multiple outputs is sufficient to conclude that it's not a function. If we look over here, each of the inputs is only mapped to one output. It doesn't matter that these two are mapped to the same output. These two are each only mapped to one output, and that's why this is a function. So this might sound, again, a bit hard to understand, but you've actually been dealing with functions for a long time. Y equals x plus 1 is an example of a function. So the domain we associate with x values and the range with y values. So when you look at this function here, it's a map. It takes an x value to a y value. 0 from x gets mapped to y1 because 0 plus 1 is 1. If x is 1, y is 1 plus 1, which is 2. So 1 gets mapped to 2, 2 gets mapped to 3, and so on. Y equals x plus 1 is a function because there is never an example of an input that's mapped to multiple outputs. In other words, if you substitute x for a number, there will only be one answer for y. You can't get two possible answers. And functions behave the way that they should really. One input generates one output. You only get one answer when you substitute a value for x, and that's why they're very important. So let's now look at the graphs of functions. So here I've provided two graphs. One is a cubic that we'll be doing a lot of work on, and one is the graph of a circle we'll be doing a lot of work on. So you can just look at these two graphs straight away and determine whether or not they are functions. How do you do that? We use the vertical line test. So a graph constitutes a function if and only if it is impossible to draw a vertical line that hits the graph more than once. What does that mean? Well, let's look at this situation here. If I draw perfectly vertical lines, note that I only ever hit the graph in red once. I only hit the graph once for every single vertical line. I can't draw a vertical line here that will hit this graph more than once. So it turns out this is indeed a function. In fact, all cubics are functions, all polynomials are functions. We'll do a lot of work on polynomials. So that's passing the vertical line test, that's why it's a function. If we look over here, this is the graph of a circle, x squared plus y squared equals 1. So it turns out this is not a function because you can easily draw a vertical line that hits the graph more than once. So essentially what that means is you have times where an x value is mapped to multiple y values. So for example, if x equals 0, 0 gets mapped to y equals 1, but also to y equals minus 1. If you input a value for x, there are sometimes multiple values for y. That's why this is not a function. But for cubics like this, if you input a value for x, you will only get one output for y. All right, let's now look quickly at function notation. So if something is a function, like this one here that is a function, we can write it in this form fx. Fx basically just replaces y, but it allows us to show the input. So if f of x is this, then what would be f of a? So f of a just means you take this equation here, and everywhere you see an x, you replace it with a. So f of a will just be the same as the above, but replacing x with an a. Now, often you will need to calculate f of a number. So f of 1, for example, means you take this original equation, everywhere you see an x, you replace it with 1. So it will be 2 times x cubed minus 3 times x squared plus 1. It's just 2 minus 3 plus 1, which is 0. F of minus 1, it's the same thing. Everywhere you see an x, you replace it now with negative 1. So if we do this, it will return just one number. The input is minus 1, the output is 2 times negative 1, minus 3 times 1 plus 1, which actually gives negative 4. So we have one input, one output. And that's what it means to be a function. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.